Inside the shadow of Geneva, under the world's surface, lies a marvel of human innovativeness and a possible harbinger of annihilation: the Monster Hadron Collider, LHC. This machine is an extraordinary device for specialists, engaging them to zero in on subatomic particles and uncover the tricky God molecule, the Higgs boson. Renowned physicist Brian Cox has made a chilling articulation that has blended responses among researchers, as it permits them to test the basic structure blocks of matter and investigate the very texture of spacetime. Yet, the monstrous energies engaged with these impacts also present critical dangers, both known and unknown. One of the most pressing concerns surrounding the operation of the huge Hadron Collider is the possible creation of smaller-than-expected black holes or other intriguing peculiarities that could have unanticipated outcomes. While hypothetical models propose that any such black holes would be short-lived and present no danger to Earth or its occupants, the chance of incidentally making power beyond our reach remains agitating. Additionally, the sheer scale and intricacy of the analyses conducted at the collider require thorough safety conventions and oversight to mitigate potential perils. The global community of specialists and researchers associated with the collider's operation is well aware of the need to prioritize security, ensuring that all investigations are conducted with utmost watchfulness and responsibility. The Large Hadron Collider, with its capacity to challenge and expand how we might interpret the fabric of reality, is not only a wonder of modern engineering, but also a central hub of contemporary particle physics, PHYS, and cosmology. Its primary objective is to examine the basic particles that make up the universe, which has significant ramifications for our understanding of existence. The LHC permits researchers to reproduce conditions only minutes after the Big Bang, giving a unique opportunity to study the Higgs boson and other fundamental particles. The Higgs boson, frequently referred to as the God molecule, was hypothesized in 1964 by Peter Higgs and others as a significant part of the Standard Model of particle physics. This model describes the essential forces and particles that comprise the universe. The discovery of the Higgs boson at the LHC in 2012 confirmed the presence of the Higgs field, an invisible field that confers mass to different particles. This discovery was a grand achievement, validating many years of theoretical work and advancing our understanding of the universe's hidden structure. However, like all major scientific endeavors, the mission for knowledge at the LHC is not without its potential dangers and moral dilemmas. The energies involved in particle collisions at the LHC are immense, and the possibility of creating new forms of matter or triggering surprising reactions cannot be totally ruled out. Some scientists have hypothesized about situations where high-energy impacts could create small black holes or other unexpected particles, raising concerns about the potential outcomes of such events. While most specialists consider these risks to be incredibly remote, the very nature of scientific inquiry involves venturing into the unknown. Brian Cox's statement, highlighting the potential to recreate a miniature Big Bang inside the LHC, underscores the tremendous significance and potential risks of this investigation. The Large Hadron Collider represents the zenith of modern scientific endeavors. However, its unprecedented capabilities also spark a central conversation about the limits and responsibilities of scientific exploration. The Collider, through its design and operation, aims to answer crucial questions about the universe, but it operates at the limits of human knowledge and technological ability. This intersection raises significant questions about the nature of scientific risk and the moral implications of such advanced investigation. One of the most astonishing parts of the LHC is its capacity to reproduce conditions only minutes after the Big Bang, offering a fascinating glimpse into the early universe. This simulation allows researchers to study particles that existed in the universe's earliest stages and explore phenomena that would otherwise be difficult to access. By replicating these extreme conditions, scientists can test theoretical predictions and refine models of particle physics. For instance, experiments at the LHC have the potential to examine the properties of speculative dark matter particles, which are believed to make up a significant portion of the universe's mass but remain elusive to direct detection. The mission to understand dark matter is driven by its significant implications for our grasp of the universe. Currently, dark matter is inferred from its gravitational impact on visible matter, but direct detection remains challenging. The LHC's experiments aim to address this challenge by attempting to create dark matter particles in the lab. If successful, this could revolutionize our understanding of the universe and potentially lead to new discoveries and insights. Such breakthroughs highlight the LHC's role as both a scientific instrument and a catalyst for momentous revelations that could reshape our perspective. Another exciting area of exploration includes the strong force, one of the four fundamental forces of nature. The strong force binds protons and neutrons within the atomic nucleus, and understanding its behavior at high energies can provide insights into the fundamental structure of matter. The LHC's ability to test strong force interactions on an extreme scale allows scientists to investigate the dynamics between quarks and gluons, the basic particles that mediate the strong force. These investigations could lead to a deeper understanding of nuclear physics and the forces governing atomic nuclei. The technological advancements driven by the LHC extend beyond particle physics. The collider's sophisticated systems for detecting and analyzing particle collisions have spurred innovations in computing, data analysis, and sensor technology. For example, the development of the World Wide Web was initially conceived as a way for scientists to share data from particle physics experiments at CERN. Today, this technology has transformed global communication and information sharing. The advances in computing and data management required for the LHC have had a wide impact across various fields, demonstrating how major scientific research can drive technological progress. However, the operation of such a powerful instrument also requires stringent safety measures and ethical considerations. The potential for unexpected outcomes, such as the creation of novel or unusual particles, demands careful risk assessment. While theoretical models suggest that the likelihood of catastrophic events is very low, the possibility cannot be entirely dismissed. This uncertainty requires scientists to approach their work with caution and transparency, ensuring that safety protocols are robust and that the public is informed about potential risks and the measures taken to mitigate them. Public engagement and understanding are critical components of scientific research, particularly for projects with the potential to impact society at large. The LHC has generated significant interest and conversation, highlighting the importance of ethical considerations in scientific discovery. The discussion surrounding the Large Hadron Collider, LHC, extends beyond the realm of physics and technology, as it touches on profound ethical, philosophical, and societal implications. As the LHC pushes the boundaries of human knowledge, it forces us to confront critical questions about the role of science in shaping the future. While it represents a monumental leap in our understanding of the universe, the potential consequences of its experiments cannot be overlooked. The very idea of manipulating the fundamental building blocks of nature raises questions about the responsibilities of scientists and the ethical boundaries of exploration. One key aspect of the LHC's operation is the idea of scientific accountability. The researchers and institutions involved in the LHC are acutely aware of the potential risks and strive to ensure that their work is conducted with the highest standards of safety. However, the complexity of the experiments and the uncertainty surrounding certain outcomes mean that no risks can be entirely eliminated. This underscores the importance of transparency in the research process, with clear communication to the public and the scientific community about the possible consequences of their work. Public trust is essential, as the LHC's findings and any unforeseen results could have far-reaching effects on society, both in terms of their scientific significance and their broader implications. Moreover, the LHC serves as a reminder of the unpredictability of scientific progress. Many of the breakthroughs achieved at the collider, such as the discovery of the Higgs boson, were not anticipated by scientists before the experiments began. The very nature of cutting-edge research means that researchers must be prepared for the unknown and be open to surprising discoveries. This unpredictability can be both exciting and daunting, as it challenges our understanding of the universe and invites us to question long-held beliefs about the nature of reality. It also raises the possibility of unforeseen discoveries that could change the course of history, whether in the realm of technology, medicine, or fundamental science. As the LHC continues to explore the depths of particle physics, it also brings to the forefront the importance of collaborative scientific endeavors. The LHC is the result of decades of international cooperation, with thousands of scientists, engineers, and technicians from around the world contributing to its success. This global collaboration highlights the importance of working together across borders and disciplines to tackle some of the most profound questions of existence. It is through these collective efforts that science can continue to advance, pushing the boundaries of what is possible and uncovering the mysteries of the universe. However, with this level of collaboration comes the challenge of ensuring that scientific progress is aligned with the values and needs of society. As we push the frontiers of knowledge, it is crucial that the ethical considerations surrounding the LHC are not only addressed by the scientific community, but also by the broader public. Society must engage in conversations about the direction of scientific research and the ethical implications of experiments like those conducted at the LHC. These discussions are vital in ensuring that the benefits of scientific progress are shared responsibly and equitably, with due consideration for the long-term consequences of such powerful technologies. The LHC, therefore, is not just a tool for scientific discovery. It is also a symbol of the complexities of modern science. It encapsulates both the promise and the potential peril of humanity's quest for knowledge. As we delve deeper into the fundamental questions of the universe, we must remain mindful of the broader context in which these discoveries take place. By balancing scientific ambition with ethical responsibility, we can ensure that the LHC and similar projects continue to enrich our understanding of the cosmos while safeguarding the future of our planet and its inhabitants. Conveying complex logical ideas to a more extensive crowd, successful science correspondence demystifies exploration and cultivates informed public talk about the suggestions and dangers related with cutting-edge logical investigations. By keeping an open discourse with the public, specialists can address concerns, disperse confusions, and construct trust in the logical cycle. As we move forward, the continued activity of the LHC and the potential for new revelations bring up significant issues about the eventual fate of logical request. The collider's capacity to test novel areas of molecule physics might prompt new inquiries and difficulties, pushing the limits of our insight much further. The quest for these frontiers will require continuous cooperation between researchers, specialists, and policymakers to guarantee that exploration is led dependably and that the advantages of logical progressions are maximized while minimizing potential dangers. The LHC remains a demonstration of human inventiveness and the pinnacle of human achievement, prepared for imitating the states of the universe's introduction to the world. This incredible machine allows us to open the secrets of the universe, revealing something truly essential and potentially world-changing. Established in 1954, CERN is one of the world's most prestigious research organizations, including 23 member states and a tremendous network of researchers. The LHC is CERN's lead project, but it is just one piece of a larger network of gas pedals and detectors that explore the subatomic world. The LHC accelerates protons to almost the speed of light, mimicking the energy of the universe right at the moment of the Big Bang. The resulting impacts create temperatures millions of times hotter than the sun's core, with a complex array of magnets directing the protons on their journey while cutting-edge cooling systems maintain the magnets at temperatures colder than space. The LHC's design is an engineering wonder, working deep underground and protected from cosmic radiation. The entire ring is cooled to temperatures colder than the vacuum of space, essential for the superconducting magnets to work. Impacts happen at 4 points along the accelerator ring, each corresponding to one of the 4 major particle detectors: ATLAS, CMS, ALICE, and LHCb. These detectors capture the repercussions of impacts, allowing researchers to filter through the debris, looking for the elusive Higgs boson, a particle key to understanding the universe's structure. The LHC isn't just a scientific tool, but a demonstration of human imagination and aspiration. It represents our quest for knowledge and our desire to understand the fundamental forces shaping our universe. However, as we push the limits of understanding, we must also consider the moral and existential questions that arise. What are the risks of exploring the unexplored? Could our quest for meaning accidentally unleash powers beyond our control? Inside the hallowed halls of CERN, where the frontiers of human knowledge are continually expanding, a revelation has emerged that has sent shudders down the spines of even the most seasoned researchers. Brian Cox, a former scientist at CERN and a respected voice in particle physics, recently made a statement that has both amazed and frightened mainstream scientists. The goal of CERN's Large Hadron Collider is to replicate a miniature version of the Big Bang, the event that birthed our universe. Cox also highlighted the potential repercussions of this goal, noting the LHC's capacity to create new phenomena, including its ability to uncover the Higgs boson and study dark matter, substances that make up a significant portion of the universe. The possibility of replicating a small Big Bang is not merely a theoretical concept. It is a real possibility within the LHC. The conditions inside the collider mirror those that existed at the universe's inception, allowing researchers to observe the beginning of existence itself. However, with such power comes great responsibility and potential risk. Imagine a scenario where something goes wrong. In 1978, Russian physicist Anatoly Bugorsky experienced an accident at the Institute for High-Energy Physics in Russia, where a malfunction caused his head to come into contact with a proton beam, resulting in serious injuries. Despite this, Bugorsky survived and continued his work, highlighting the immense power and potential dangers of particle accelerators. The risks associated with a particle collider like the LHC are not to be taken lightly. The potential for unforeseen reactions and the manipulation of the very fabric of reality are real concerns voiced by some in mainstream science. One major fear surrounding the LHC's experiments is the possibility of creating miniature black holes, regions of space-time with such intense gravitational pull that not even light can escape. If the LHC were to produce such a phenomenon, even on a small scale, it could hypothetically consume the Earth from within. However, some scientists have assured the public that any black holes created would dissipate quickly. Understanding how the LHC could create a black hole involves the basic mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy is so great that it could distort the fabric of space-time itself. Imagine a trampoline stretched tight, with a heavy object dropped onto it. The surface would bend, and if the weight were sufficient, it could create a hole. This analogy illustrates the LHC's potential to create a gravitational anomaly. This intriguing yet disturbing possibility has even caught the attention of prominent physicists such as the late Stephen Hawking, who warned that the Higgs boson could become unstable at extremely high energy levels, potentially triggering a catastrophic event known as vacuum decay, which could destroy the universe. Renowned cosmologist Sir Martin Rees has also expressed concerns about particle collider experiments, including those at CERN. In his book, Our Final Century, he considers the potential dangers of collider experiments, including the creation of vacuum instability. This instability could hypothetically trigger a phase transition that would echo through space-time, leading to a catastrophe of unimaginable proportions. While these scenarios remain highly hypothetical, even a slim chance warrants serious thought. The stakes are extraordinarily high, and the margin for error is razor-thin. Several scientists have carefully evaluated the potential dangers associated with their experiments and implemented rigorous safety protocols and protections to mitigate any potential risks. Scientific inquiry inherently involves a level of uncertainty, particularly when delving into unknown realms. The pursuit of knowledge has always been accompanied by risks, but it is precisely this drive to push boundaries that has propelled human progress. The LHC represents the pinnacle of decades of scientific advancement and global collaboration. Yet beneath its impressive exterior lies a domain of profound scientific inquiry, laden with potential dangers and moral considerations. The collider's primary goal of unraveling the secrets of particle physics has led to groundbreaking discoveries, including the elusive Higgs boson. However, the immense energies generated within its confines also raise concerns about the potential devastating consequences of such an endeavor. While extensive safety measures are in place to mitigate risks, the possibility of catastrophic events. As we continue to probe deeper into the subatomic world, the consequences of our actions become more profound. The LHC, as a symbol of human ingenuity, challenges us to reconsider not only what we know about the universe, but also how we approach the future of science. As the collider pushes the boundaries of particle physics, we must recognize the ethical and philosophical implications of this research. The potential to make groundbreaking discoveries is exciting, but it also comes with a responsibility to ensure that these advancements do not outpace our ability to understand and control them. The LHC's ability to create conditions that replicate the earliest moments of the universe opens new avenues of exploration in cosmology and fundamental physics. Yet, these experiments raise questions about the safety of manipulating forces at such extreme scales. Scientists must remain vigilant in their assessments of the risks involved, ensuring that their work does not inadvertently bring about unforeseen consequences. The ongoing debate about the LHC's potential dangers serves as a reminder of the delicate balance between discovery and caution. While the LHC's primary mission is to investigate the fundamental forces and particles that constitute our universe, the philosophical and ethical questions raised by its operations cannot be ignored. The collider's capacity to explore the unknown should be coupled with a deep respect for the potential consequences of such exploration. The pursuit of knowledge is a noble endeavor, but it is essential that we approach it with both intellectual curiosity and a sense of responsibility toward the future. In the end, the work being done at CERN and through the LHC is not just about understanding the universe. It is also about grappling with the fundamental questions of what it means to be human, to explore, and to create. The discoveries made in the years to come may offer us profound insights into the nature of existence itself, but they also require us to consider the ethical and existential challenges that accompany such advancements. As humanity continues to push the limits of knowledge, we must do so with a collective commitment to ensure that our pursuit of understanding benefits not just the scientific community, but all of humanity.